Hi everyone. So today I'm going to discuss about 11.1. So here we learn how we can find the derivative of logarithmic functions. So today our topic is this one, derivatives of logarithmic functions. So in 1330 you have learned about logarithmic functions, especially about this function y is equal to ln x. Here the idea is logarithm of natural base to the x. And typically for the short notation we use as lnx. So this is the most important one for this section. If y is equal to lnx, then derivative is equal to 1 over x. So if we derive lnx with respect to x, it becomes 1 over x. And secondly, if y is equal to ln u, here u is a differentiable function of x, then dy over dx is equal to 1 over u times du over dx. So specialty in here is we have used chain rule. So first we derive this ln u with respect to u, then it becomes 1 over u. After that we derive u with respect to x, so it is du over dx. So especially you have to use this one and this one for future calculations. Now let's look at some examples. This one is given some problem. So find the derivative of each of the following. This one is ln and this polynomial. So here you can use your substitution as this is u. So then you can obtain 1 over u. So this is the u times du over dx. So you have to derive this u with respect to x. Then if you derive this polynomial with respect to x, this becomes 4 times x to the power 3 minus 3. So finally we can write it as like this fractional form. Okay, now let's look at this one. So here also you can substitute this as your u. 2 times x to the power 6 minus 3 times x plus 2. Then you can take this one as a constant, no need to worry about this one. Then 1 over u is this is your u, and then take the derivative of this one, so it becomes 12 times x to the power 5 minus 3. So finally after doing simplification you can write like this way. And if you look at this one, third one, so especially here it is a fraction, so you have to use quotient rule definitely. So here you have to take the derivative of this first term and then minus our second term, divide by 2x plus 1 square. So this is your final answer. Then we are going to find the derivatives of logarithms by using properties of logarithms. Actually, properties of logarithms you have learned in 1330 course. So these are the logarithmic properties for base of a logarithms and natural logarithms. Actually, base a logarithms mean this one, and base e logarithms means natural logarithms. Base e, here base a. So in typically base e we write it as ln form. So here it is exponential, and here it is multiplication. We can write it as addition, and if it is a fraction we can write it as a subtraction, and if it is a power m to the power p we can take it in front to this logarithmic form, so p times ln m. So these are the basic important things. Now let's move to our problem. Use logarithmic properties to find derivatives for this given function. So first, if you look at cautiously, you can think this is your m and this is n. So you can write this product as a summation ln x plus ln x to the power 5 minus 2 to the power 10. So again you can distribute, because this is a power, you can take it in front of this term, so it is 10 times ln x to the power 5 minus 2. Then take the derivative of both terms. Now it is easy, so we can obtain it as 1 over x plus the derivative of second term, and this is your final answer. And for this one, at the first glance we can see this is a hard one, but if you look at cautiously, first we can take this in front because this is a power with respect to this logarithm, and then you can see this is fraction, so we can write it as a subtraction of two terms. Especially for this one, it becomes 1 divided by 3. The reason is this is cubic root, and for this one we can write it as generally. Then I think it is easy, you can take the derivatives in normal way. So after taking derivatives, this is your final answer. So this is also somewhat important thing. If we are given in the form of a, so this is a general form, so we can write any term by using this formula. Actually in 1330 course we learn about these things. So if log a to the power a to the base x, we can write as ln x divided by ln a. So as an example, if we need to find the logarithm derivative of this one, we can reduce it into this form. So ln a means 4. So ln this polynomial divided by ln 4. So we can take this as a constant. You can find the value of this one, and then you need to take the derivative of this term. So this is a constant times derivative of this one, means this is your final answer. Okay, thank you everyone.